Okay, so let's look at the one that says commutative property first. It says, changing the order of the factors does not change the product. Where have we heard that before? Where have we heard something just like that before? Zadie?
In our book.
Okay, but what do you mean by that? Where in our book? Who can help her out? Where have we heard commutative property that sounds a lot like changing the order of the factors does not change the product? Kingston. When we were doing the addition properties. So here we have the commutative property of multiplication that says changing the order of the factors does not change the product. Well, when we were talking about addition and subtraction, we learned the commutative property of addition said changing the order of the addends does not change the sum. That's because addition and multiplication are related. So, for example, 3 times 2 equals 2 times 3. 3 times 2 equals what? Class?
6.
2 times 3 equals what? Class?
6.
So again, here we see it does not change. Okay, go ahead and look at identity property, the next page. Now we have identity property. Who's heard of identity property before? Aaron, when did you hear about identity property? When do you remember hearing about identity property? Louder. In lesson 1? What do you mean in lesson 1? We've had like 3 lesson 1s. Smith, can you help her out? Come on, guys, please have an answer before you put your hand in the air.
In the addition section.
Good. In the addition section, we learned that if you add 0 to any number, the answer is that number. Well, it's a little different in multiplication because in multiplication, the identity property has nothing to do with 0. So don't get that confused. The identity property of multiplication has nothing to do with 0. It says multiplying a factor by 1 equals the factor. Sorry, where are you? So 20 times 1 equals 20. So it's similar to the identity property of addition in that our answer is the same as the number. But it's different because we're not adding 0. We're multiplying by 1. So identity property of multiplication has to do with 1, not 0. So do not get those confused. And the reason is, look at the next one. Look at the next. We have an extra multiplication property that we did not have an addition version of. We have the 0 property of multiplication. That should help you to understand, hey, identity property has nothing to do with 0 because there's a 0 property of multiplication, which says that multiplying a factor by 0 equals 0, no matter what that factor is. So 54 times 0 equals 0. So the identity property has to do with 1. Multiplying any number by 1 equals that number. The 0 property has to do with 0. We can tell because it has 0 in the name. So 54 times 0 equals 0. Any number times 0 equals 0. Look at the next page. Our next page, we are past the the multiplication properties. There are more, but we're only going to learn about 3 today. The commutative property of addition, of multiplication, which is just like the commutative property of multiplication. I'm sorry, wait. The commutative property of multiplication is just like the commutative property of addition, where it doesn't matter the order the factors in. So again, that key word in commutative property is order. Identity property of multiplication is different from the addition property because we're not dealing with 0, we're dealing with 1. Any number times 1 equals that number. The 0 property of addition has to do with, the 0 property of multiplication has to do with 0. Any number times 0 is 0. Now we're to the division rules. There are 2 separate division rules. First is zeros in division, which says when you divide 0 by any number, non-zero number, that means any number that is not 0, the quotient is 0. For example, 0 divided by 5 equals 0. So if you divide 0 by any other number, the answer is 0. Because if I have 0 apples and I divide them between 5 kids, how many apples is each kid going to get? Zari?
1.
Please listen to my question. Zari, I want you to answer this. Zari, if I have 0 apples and I give them to 5 kids, how many apples is each kid going to get?
0.
0, because I didn't have any to give away. Look at this sentence. It says, it is not possible to divide a number by 0. Why do I not see anybody circling that? That's a little bit frustrating because I've said anything I do on the board, you do on your paper or in your book unless I say the words, do not do this. Did I say, do not circle this? What did I say exactly before I circled it or as I circled it? Victoria? What? I did say something. What did I say right before or as I was circling this number? This sentence. Zari.
Write this.
I didn't say write this. Now I know nobody's even listening to me. So why am I even here? I could have just stayed home today. Smith?
Circle this.
I didn't say circle this. I said pay close attention to this sentence. So even though I didn't say circle this, did I say don't circle this? And I said something like, that means you better pay attention to this and you better listen to this, so you better circle it and emphasize it. I said pay close attention to this sentence as I circled it. Which meant without saying the word circle it, you should have been circling it and emphasizing it. It is not possible to divide a number by 0. You cannot do this. Do not write this. You cannot do this. You cannot have a 0 as a divisor because the divisor tells you how many groups you're putting it into. Can I put something into 0 groups? If I have 5 apples, can I put them into 0 groups? Is that possible? No, because no matter what, I have one group. I have one group of 5. It is not possible to put them in 0 groups. Because if I have 5 objects, well, I automatically have one group. So this is not possible. However, you may see where you have 0 objects and you put them into 5 groups, which means you just have 0. I can have 5 piles of nothing. Just because you can't see it, I can say there's a pile of nothing right there. That doesn't seem right, but that is possible. Anytime you divide 0 by a non-zero number, that means a number that is not 0, the answer is 0. Okay, now look at ones in division. Ones in division is our second division rule. It says when you divide any number by 1, The quotient is always the same as the dividend. For example, 7 divided by 1 equals 7. If I have 7 apples and I give them to one kid, how many apples does that one kid get? Carla?
7 apples.
7. So if I have 7 apples, I give them to one kid, that one kid ends up with 7 apples. The next part, there are 2 parts to this rule. When you divide any non-zero number by itself, that means any number that is not 0 by itself, the quotient is always 1. So for example, 4 divided by 4 equals 1. If I have 4 apples and I give them equally to 4 kids, how many apples will each kid get? Zadie? 1. So 1's in division says when you divide any number by 1, for example, 7 divided by 1, the quotient, which is the answer, is always the same as the dividend. That's the first part of a division sentence. So 7 divided by 1 equals our dividend, which is 7. When you divide any non-zero number, that means a number other than 0, because you can't do this, because you cannot have 0 as a divisor. When you divide any non-zero number by itself, the quotient is always 1. 4 divided by 4 equals 1. Okay, so now let's look at our book. Finger a pencil on example 1. Carla, is your finger a pencil on example 1? Okay, read in your head while I read out loud. The table shows Jenny and Cliff's chores. Jenny earns $3 for each chore, and Cliff earns $2 for each chore. How much does each person earn for completing chores? So let's look at this question. How much does each person earn for completing chores? Now I know to find the answer unit, I need to look at how many or how much, and look at the word that comes after. Well, the word that comes after is does. Is our answer unit going to be does? No. But we know how much refers to what. Look at the rest of the problem. How much would refer to what? This is where you're inferring. How much would refer to what? You have to make an inference. How much what? Kingston? Zari, down a little bit. It was good at first, so you don't need to mess with it. It's good right now, so you don't have to mess with it. What? Money. We know if we're talking about $3, $2, how much does each person earn? Well, you earn money. So we know the word money could go here. So that means that is our answer unit. I'm going to move it. Money can go there. So that is our answer unit. That means that not only is our answer going to be this much money, we're also looking, or this many dollars, we're also looking for money as at least one of our factors or pieces of our equation if this is division. If we keep reading the sentence, how much does each? We see the word each, which means multiplication or division. We know if we see each or times as many or times as much, we're doing multiplication or division. We're not going to see both in one problem. It would not be possible. Because remember, each means you're doing groups. Times as much or times more or whatever means you're comparing the amount one has to the amount another has. Whatever word comes after the word each is our other, well, wait, hold on. Hold on. It's not always whatever comes after each, because do we have, hold on. Sometimes, let's see, we have to figure out, well, what did they do? In this case, it's going to be chores. Chores is going to be our other unit. Because each person is just saying, okay, there's 2 people. But chores is what they did. So we know from the question they earned money for each chore. So chore is going to be the other unit. How many chores did they do? Not how many people, but how many chores did they do? So now we know we're looking for money and we're looking for the number of chores. So let's reread the question. The table shows Jenny's and Cliff's chores. Well, that doesn't really tell us money or how many. It does say the word chores, but it doesn't tell us how many. Where do we see how many chores they did? Where do we see the number of chores? Cullen?
On the piece of paper.
The little table to the side. So how many chores did Jenny do, Cullen?
2.
2. How many chores did Cliff do?
3.
3. So there's our other units. Those are the number of chores. Jenny did 2 chores. Cliff did 3 chores. Now let's keep reading because now we need to find out the money. We have the number of chores that each did. Now we need to find the amount of money. Jenny earns $3 for each chore. So there's 1. Jenny earns $3. And Cliff earns $2 for each chore. So there's our other number. Jenny earns $3. Cliff earns $2. So now we have to make a number sentence. We know the amount of chores, we know the amount of money. Are we going to end up, our answer unit is money. So we need to figure out, in the end, are we going to end up with more than $3 or $2 or less than $3 or $2? If we're taking it and they're doing chores and they get that much for each chore, are they going to end up with more than $2 or $3 or less than $2 or $3? Aaron, more. Which operation, multiplication or division, means we end up with more? Multiplication. So that means we have to be doing multiplication. So now we have to complete each number sentence. Well, we're not going to take 2, 3, $3 and $2 and put it into one equation. Because we're just trying to figure out, okay, how much does each person make? How much does Jenny make? How much does Cliff make? So first, let's look at Jenny. First, we need the number of chores. Well, we look at our table, we see Jenny does 1, 2 chores. So we'll put that in our multiplication problem. Then we're going to put how much money she gets for each chore. Well, our problem says Jenny earns $3. So we're going to put $3. Do not forget that dollar sign because 3 does not represent something other than dollars. Once we do that, we take the 2 chores, we repeat them 3 times, we'll get the answer. So 2 times $3 equals what, class?
$6.
$6. So how much does Jenny make on her chores? Michaela? $6. Okay, now are we done with the problem? Is the answer Jenny makes $6? No, we have to figure out how much each person makes, which means we've solved half of the problem. Now let's look at Cliff. We're going to do the same thing. We're going to take the number of chores. If we look at our table, we see he does 1, 2, 3 chores. We're going to multiply it by the money he gets for each chore. Our problem says Cliff earns $2. And then we're going to take that $2, repeat it 3 times for the chores. 3 times $2 is what, class?
$6.
$6. Is there anything else that we need to do to figure out how much money they each get? You can show me. No. So that means each person earns, class?
$6.
$6. Pay close attention to this sentence. The order in which the factors are multiplied does not change the product. We know why. Because it's the same reason that it doesn't matter in addition, and we looked at those anchor charts earlier. So what tells us that the order in which the factors are multiplied does not change the product? What tells us that the order in which the factors are multiplied does not change the product? Carla.
Commutative property of multiplication.
Good. Commutative property of multiplication. Again, do you see the pattern? Where addition has commutative property of addition and multiplication is really just repeated addition. $3 plus $3 equals $6. And $2 plus $2 plus $2 equals $6. So again, that's the pattern. Multiplication and addition are related, so that means we have similar properties. Okay, helper number 1, please sanitize, erase, sanitize. Okay, we have a key concept box. Whenever we have a key concept box, what do you need to do with the information in that key concepts box? Zari.
Just like in any other subject that has a box in it, we read the important information.
Okay, but in math, there's something even more that we have to do. Whenever we have a key concepts box, what do we need to do? I told you this when we had it with the addition and subtraction rules. What do we need to do if we have a key concept box in math? Victoria? I can't hear you. That's what Zari just said. You memorize it. You're not going to, a lot of you aren't going to do that, but you should. I'm telling you right now. I can't make you memorize it, but you should. Memorize it. I can tell who did memorize it and who did not by looking at the tests. Okay. Yes. Okay. So just like with multiplication, with addition properties and subtraction rules, if you have a key concept box, you must memorize it. So let's look at the first property. Please read to us the first multiplication property, Zari. Zari, please turn your camera on. Leave it on. Do not turn it off.
Concept. Multiplication properties.
I'm asking you to read the first multiplication property, so you don't have to read us the title. We already know what this shows us.
Commutative property of multiplication. When multiplying, the order of the factors does not change the product.
That's what we saw in example 1. So Zari, read us those examples. What's the first example?
What'd you say?
Read us the examples. What is the first example?
4 times 2 equals 8.
So, hold on, I said just the first example, Zari. So if we have 4 items and we repeat those items 2 times, we end up with 8 items. Okay, Zari, read us the second example. You were unmuted. You were muted.
2 times 4 equals 8.
Good. So if we have 2 items and we repeat them 4 times, 2, 4, 6, 8, we end up with the same number. Okay, thank you. So that's the commutative property. It does not matter the order. So put a box around that key word. The order of the factors does not change the product. Kingston, read us the next multiplication property. Louder so that we can hear you, otherwise I have to call on somebody else, which means you get a consequence.
Identity property of addition or multiplication. When any number is multiplied by 1, the product is that number.
So again, identity means 1, not 0. It's different from addition because identity property of addition, we had 0. Well, in identity of multiplication, we're talking about 1. So 1 is the key word. 1 is the key word. Kingston, read us that example.
4 times 1 equals
4 times 1 equals 4. If I take 4 and I repeat it 1 time, I still have 4. Okay, now the 0 property of multiplication. Read to us about that, Victoria.
0 property of multiplication. When any number is multiplied by 0, the product is 0.
Good. When any number is multiplied by 0, the product is 0. The key word there is 0. So, Victoria, tell us the example.
3 times 0 equals 0.
3 times 0 equals 0. If I have 3 objects and I repeat it 0 times, that means I've basically gotten rid of them. I end up with 0. Because I can't repeat actual objects 0 times. That means I never had it to begin with. Okay, so does everybody understand the multiplication properties? There are 2 more that we will learn later. But commutative, doesn't matter the order you multiply in. Identity, anytime you multiply by 1, the answer is that number you multiplied. When any number is multiplied by 0, the answer is 0. Doesn't matter what it is. It could be 12,364,282. If you multiply it by 0, you still get 0. Okay, go ahead and turn. Okay, so before we get to example 2, we have another key concepts box. It says the following rules can help you with division. So, do we have division properties? Do we have addition properties, Carla? I'm sorry, do we have division properties?
Yes.
Do we have division properties, Cullen?
No.
No. Carla, does it say division properties?
No.
No, and it's just like subtraction. We had no subtraction properties. But some of you did not follow my tip to memorize the key concept box. So when you saw a problem that looked like this, you said that that was the identity property. Well, that's subtraction. Is there such thing as an identity property of subtraction? No, because there are no subtraction properties. Well, just like there are no subtraction properties, there are no division properties. We have division rules. So let's look at the first one. Tell us the first division rule, Smith.
Zeros in division. When you divide 0 by any non-zero number, the quotient is 0.
Good. So, read us that next sentence, which is very important.
It is not possible to divide a number by 0.
It is not possible to divide a number by 0. That means your divisor, your second number in a division problem, can never, ever, 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 ever be 0. If it is, you are wrong. You are incorrect. It is not possible. Now I know that goes against everything you've learned because the smaller number is never supposed to be first. Well, if it's a 0, it is. That's the only time. So, Smith, tell us the example.
0 divided by 5 equals 0.
Good. If I have 0 objects and I put them into 5 groups, how many is in each group, Smith?
0.
0. The key word for zeros in division is divide 0. That is the key word so that you know it's zeros in division. Because when you get to your test or your independent practice or your homework and it asks you for a division rule, you can't just write division rule. You have to write either zeros in division or the next one, which is what, Zadie? What is the next division rule?
Ones in division.
Ones in division. This has 2 parts. This rule has 2 parts. What's the first part, Zadie?
When you divide any number by 1, the quotient is always the dividend.
So the first part of that ones in division is when you divide any number by 1, doesn't matter what the number is, if you divide it by 1, the quotient, aka the answer in a division problem, is always going to be the same as the dividend, the first number in the division problem. So give us that example, Zadie.
7 divided by 1 equals 7.
7 divided by 1 equals 7. If I have 7 apples, I put them into one group. How many apples do I end up with in that group, Zadie?
7.
7. So the key word, the key thing that you're looking for is dividing any number by 1. If you see divided by 1, you know the rule is ones in division. Now let's look at the second part of the rule. Aaron, what is the second part of the ones in division rule? Loudly.
When you divide any non-zero number by itself, the quotient is always 1.
So if you take a number that is not 0 and you divide it by itself, the quotient or the answer is always going to be 1. So the key words is divide any non-zero number by itself. If you have a number divided by that same number, the answer will always be 1. Give us the example, Aaron.
4 divided by 4 equals
4 divided by 4 equals 1. Because if I have 4 objects and I put them into 4 groups, how many is in each group? 1. Okay. Make sure that you pay close attention. You're looking for these key things in all of these boxes. Make sure that you are memorizing the key concept boxes. Okay, everybody, finger or pencil on example 2. I'm waiting for everyone to have their finger or pencil on example 2. Scoot your chair in. All the way. Read in your head while I read out loud. There are 9 party favors and 9 guests. How many party favors will each guest get? Well, let's look at our question first. We have how many party favors will each guest get? Let's look for those patterns that we see in all of these problems. The word or words after how many is what? The word or words after how many is always what, Smith?
The unit.
Which unit specifically? Because now we have multiple units that we have to pay attention to now that we're doing multiplication and division.
The answer unit.
The answer unit. So whatever our answer is, it'll be blank party favors. Whatever the answer unit is will also be at least one of the units in our division problem, in our equation. So now, how many party favors will each guest get? Well, I see each a lot. There's another pattern. What does each almost always mean when you see it in a problem? Aaron. Can't hear you.
It means you're doing multiplication or division.
It means we're going to end up doing multiplication or division. Make sure you're not just circling and boxing and underlining. Make sure you're also labeling. Because otherwise you don't, when you go back, you don't know why you circled or boxed or underlined. So each means we're going to be doing multiplication or division. What other words do we see sometimes? If we don't see each, we'll see something else if we know we're going to be doing multiplication or division. Michaela? But more than just times, because if we only see times, that might just be the unit. If we only see times, that might just be the unit, like the times they went to dance class in the problem we had the other day. But I have to see more than just the word times. What else do I see? Come on, guys. Smith?
As many.
Times as many or times more. I will either see each or times as many or times more. All those words tell me I'm going to be doing multiplication or division. Then, what do I know about the word, about the thing that comes after each? What do I know about whatever thing comes after each?
It's our other unit.
It's probably going to be our other unit. In this case, we have guest. which means that's our other unit. Now sometimes, like in example 1, we have to look a little further into the question. Because remember in example 1, we had each person, but the other unit was actually chores, because we didn't really know a number of people. But we knew a number of chores. We weren't going to repeat it by people. They didn't get $2 per person. They got $2 per chore. But in this case, it makes it easy for us. We don't have anything else after. So it's going to be guests. So that means we have to go through and we have to find a number of party favors and we have to find a number of guests. Then we need to figure out, okay, am I going to end up with more than the number of party favors they tell us or less? So let's go. There are 9 party favors and 9 guests. Well, I see 9 party favors and I see 9 guests. Now I know I'm taking these party favors and I'm giving them to the guests. So if I'm taking 9 party favors and giving them away, am I going to end up with more or less party favors in the end? Carla?
Less.
Less. So multiplication or division, which one tells us our answer will be less? Carla?
Each will talk less.
Carla, listen to my question, please. I have multiplication or division. Which of those operations will give me a smaller answer? I know I'm not going to end up with more than 9 party favors, so that means I'm going to end up with less. Which of those operations tells us my answer is going to be less?
Division.
Division. So that means we are dividing. So we have to take our units, our 9 party favors, and our 9 guests, and we have to divide them. Unless we have a 0, the bigger number always goes first. Unless there is a 0. If there's a 0, well, it doesn't matter what the other number is, the 0 is going to go first. Because can a 0 ever be our divisor? You can show me. No. In this case, our numbers are the same, so we'll just do the 9 party favors divided by the 9 guests, because we're taking 9 party favors, we're breaking them up into 9 groups. We end up with what? 9 divided by 9 equals, Zadie?
1.
1. Because if I have 9 objects and I break them into 9 groups, each group will have 1. How else do I know that answer without even having to think, okay, 9 objects, 9 groups, 1 in each group? How else do I know that the answer is going to be 1 if I'm doing 9 divided by 9?
Because it's a basic fact.
Nope. Kingston?
Unity property of multiplication.
Nope. Are we doing multiplication right now? So would a multiplication rule? Nope. Aaron? Okay, well, which one? Carla?
Ones in division.
Ones in division. Because ones in division tells us if we divide a number by itself, the answer will be 1. Come on, guys. The whole point of this lesson is to learn these division rules and multiplication properties. So if I'm asking you, what other way can we tell that 9 divided by 9 is going to be 1 without even thinking of groups or objects? Well, the answer is because of the ones in division rule. The ones in division rule tells us any non-zero number divided by that same number or itself is 1. So if we see a number divided by that same number, we don't even have to think about it. We know the answer is going to be 1. Because if we have 157 divided by 157, is this a basic fact? Is that going to help us knowing basic facts? No. What will help us to solve this number? Because we don't know how to do this. We don't know how to do that yet. But what will tell us, okay, the answer is 1. What will tell us that no matter what? Colin.
Ones in division.
Ones in division. Any non-zero number divided by the same number is 1. So, since there are 9 party favors and 9 guests, Each party favor will get what? I'm sorry, each guest will get what? Michaela? One party favor. Okay, now let's look at the guided practice. It says, identify the property or rule shown by each question. So are we trying to find an answer for numbers 1 and 2? You can show me, don't tell me. Are we trying to find an answer, a number answer for numbers 1 and 2? No. We are trying to find the property or rule shown by each equation. If it is a division problem, are you going to have a property as the answer? Show me, don't tell me. No. If it is a multiplication property, are you going to have a rule for the answer? No. If it is division, are you just going to write division rule? No. What are you going to write? Zari?
The division rule.
Okay, so what are you going to write? You're not just going to write division rule. You're going to write what? Smith?
Zeros in division or ones in division.
Zeros in division or ones in division. You have to figure out which one it is, and then you have to say the name of the rule, not just subtraction rule. Okay, number 1, 12 times 0 equals 0. Cullen, what property or rule is shown? First of all, is it going to be a property or a rule?
It's a rule. Property.
So think before you say your answer, because what you didn't think before you said the answer, you just said it. But does multiplication have rules?
No.
So is it going to be a property or a rule?
A property.
Property. Which property? What is the key word here, the key number that tells us exactly which one it's going to be?
0.
0. So that means, which property is it?
0 property of multiplication.
0 property of multiplication. We see a multiplication symbol. We see a 0, which is that key word or number. Yes?
You write your active cursive.
What?
You write your active cursive.
Yes, we did. Now let's look at number 2. Me. We have 8 times 5 equals 5 times 8. Carla, first of all, are we going to be writing a property or a rule as the answer?
We're going to write a property.
How do you know that? Because we have what operation symbol?
We have a multiplication.
Good. Now, what is the key thing that you see here that tells you which rule to follow? What do we have? We see numbers in different, what? What?
I see the number in different order.
In different orders. Order is the key word or the key thing you look for in which property?
Commutative property
Of?
Multiplication.
Good. Commutative property of multiplication. Now, those of you that have your basic facts memorized, what is 8 times 5? What is 8 times 5? Aaron? 40. What is 5 times 8? Colin?
40.
40. Okay, so look at the independent practice. Everybody look at independent practice when you finish writing the answer to number 2. Numbers 3 through 8, you're doing the exact same thing as numbers 1 and 2. Be careful, watch out, look at the symbol. Don't just quickly glance and then guess. Look at the symbol, look for those key words or key numbers. Numbers 9 through 12, you are finding the unknown and writing the property. So you're still doing this, but you also have to find the unknown. So you need 2 parts to that answer. You need whatever the unknown equals, you need the property or rule. Yes, Smith, quickly.
Are we allowed to look back in our book if we can't remember all of them?
Yes, always. The only time you cannot look back in your book is a test because you don't have your test. But anything else, independent practice, homework, guided practice, check my progresses, reviews, yes, go back in your book. I do not expect you to already have it memorized when we just talked about it like 10 minutes ago. Do not expect yourself to have it memorized. Look back. You guys do yourself such a disservice. That means you are hurting yourself by not looking back to make sure that you have the right answer. Zara, you should not be starting yet. Put your pencil down right now. You have not listened to a thing I said because you started. That is a consequence. I have to figure out how that will be a consequence for those of you at home. I think it's going to be lost points on homework assignments because you need to be listening. Now look at the back. Numbers 13 through 15 are word problems where you are going to have to do multiplication or division. Use the properties to help you. Make sure you read the whole question and answer every part. So if there is a part that says, write a variable, well, make sure you have a variable. You always have to have an equation, the answer. You always have to have an equation, the answer, and the unit for the answer. Make sure you have the correct unit. If it also tells you to write the property you used, write the property you used. Number 16 and 17 are critical thinking. Number 16 will have math as well. So you'll have to really think and think, okay, what is this asking me? How do I set this problem up? Number 17 is asking you a question with an answer in words. So we don't have time for that right now. We can do that. Well, let's look at the homework really quick because we have a couple minutes. So now look at the homework. Numbers 1 and 2 are just like numbers 1 and 2 on the guided practice, and numbers 3 through 8 on the independent practice. Now look at the next page. Numbers 3 through 5 are just like numbers 9 through 12 on the independent practice, where you have to find the unknown and write the property. Number 6 is a word problem. Number 6 is a word problem, so you need to make sure to find the important pieces of information. It will help you to box, circle, underline, and label them, even when you're doing independent work. And then numbers 7 through 11 are vocabulary. Figure out exactly what you're supposed to do. Make sure you fully answer the question so it is clear what you mean. Then number 12 is a multiple choice question. Make sure you look closely at the question and look closely at the answers. Okay, so for now, go ahead and put your books away. Put your anchor charts in your math folder.